Okay, this is the makeup session for the 22716, and this has to do with fundamental theorem of calculus, and so this was just where you integrate and you plug in your bounds. Okay, if you try to integrate a derivative, all you're doing is plugging in your bounds, and I'm going to skip down to this one. This we also called second fundamental theorem of calculus. If you derive an integral, you are going to plug in your upper bound in for t and then apply chain rule. Technically you would do minus and then do the same thing with the lower bound, although that lower bound on the AP test is always going to end up being a number. Okay, let's get into some examples. So you're going to do number 1 on your own. It's just a basic integration problem. I'm going to let you skip 2. That's on another packet. You're going to do 3 on your own, and then we're going to do 4, 5, and 6 together. Okay, so the first thing is, if you're integrating a derivative, okay, the only thing you're going to be doing is just plugging in your upper and lower bound, okay, obviously with the minus sign in between it. That's it. Okay, that problem looked maybe weirder than it was. All right, number 5. This is the graph of f prime, and we want to know, well, what is f of 1? Okay, well, how do you go backwards from a derivative? You integrate. Okay, so if I'm trying to integrate from 0 to 1 of f prime of x, okay, I'm talking about how do you find that area of that shape right there? That's what the integral would be. Okay, so that would be 1/2 times base, which is 1 times height, which is 6. Okay, so that's 3. However, look at this other little piece right here. Remember when we integrate, we have a plus c. All right, this right here is our plus c, so we need to add 5 to it. And we had some problems like this on our AP assignments earlier in the year. Okay, number 6. Okay, deriving an integral. This is straight up second fundamental theorem of calculus. So we're going to take x squared and we're going to plug it in for t. Okay, so I have x squared, and then that whole thing is being cubed, and then we also got to multiply by the derivative of x squared. Now, technically, you would want to do the same thing with the lower bound, but at some point you're going to multiply by 0. Excuse me, that whole thing goes away. And so now you got to think about, okay, well, what do I have left? Well, this is x to the 6, and then we also have a 2x, so our answer ends up being E. Okay, you're going to do, actually, I'm going to let you skip 7. This packet's pretty lengthy, so there's a few that are repeats. I'm going to let you skip. You're going to do 8 on your own. That's a U substitution problem. And then we're going to work 9 together. Okay, so again, this is one of those where they give you a graph, but then they ask you about something else. And here, they kind of tell you a little bit of information about the graph, and then they want to know what is g prime of 3. So the first thing we need to do is say, well, what is g prime of x? All right, well, that means I'm going to have to plug in the upper bound, so f of 2x. So I'm going to go times the derivative of the upper bound. And again, I'm going to minus something times the derivative of 0, which is 0. So I don't even need that second part. All right, now in order to do g prime of 3, okay, well, 2x, that would be 2 times 3, which would be 6. So this is the graph of f. So I'm locating f of 6. Looks like that is -1. And so I have -2. Okay. If we turn the page, you are, I'm going to let you skip 10 and 11. Again, these are not bad problems. There's just too many really in this packet. You're going to do 12 on your own. Okay, you're going to do 13 on your own. And then I'm going to let you skip 14 and 15. You're going to turn the page. You're going to do 16 on your own. It's a graph problem. We've done this before. 17, we're going to skip 17. We're also going to skip 18. We're skipping a lot in this packet because it is pretty lengthy. All right, and then we're going to work 19 together. Okay, so when you're looking at this problem, it gives us some information, pizza being taken out of the oven, and then it gives us the rate at which the temperature of the pizza is changing. Okay, that is the rate. So if we want to say to the nearest degree, what is the temperature of the pizza, okay, then I want to go backwards from the rate. I need to integrate from 0 to 5 of this thing right here. Now this is a calculator problem, so although we actually do know how to integrate this by hand, we're going to do this in our calculator. And so in our calculator, I'm going to clear some stuff out. It's always just a good idea to kind of clear everything out, clear your variables, all that same stuff. So I'm going to integrate, which was option 2, and then I'm going to integrate negative 110 e to negative 0.4, and you can use t here or you could use x. I'm going to step here, I need the e. Second e to negative 0.4 t. Okay, make sure you close the parentheses on the other end of that, and then comma t, comma, and then if I go 0 to 5, what that's going to allow me to do is find out the change in temperature from 0 to 5. Oops, I'm not pressing these buttons hard enough. There we go. I made another mistake. You probably caught it. There we go. And so that's the change in temperature, okay, from 0 to 5. The pizza has cooled off this much. And so if you notice, there is an answer choice that says 238. But think about what we found. From 0 to 5, the pizza has cooled 238 degrees. But it was 350 to start with. Okay, so this is kind of like our initial condition. So you've either got to like think it out logically at the end, or you've got to add this to 350. It's like your initial condition. It's like your plus C. Okay, so in our calculator, I would add this answer to 350, and we get 112 when we round to the nearest whole. Okay, so that was 19. You're going to do 20 on your own. Okay, turn the page and actually let you skip 21. That's a pretty long problem. We're going to do something like that when we get to AP review. 22 and 23, pretty good problems. We've done some like that. So I should try those. Whoops, sorry. 23 we're going to do together though. This will be the last one we do together in this video. So we have a function twice differentiable, and then they give us this information, evaluate this. Okay, so remember that when we have things like minuses, we really can just go ahead and split this up into 2 different derivatives. Now I'm even going to bring out the 5. Okay, so this is 2 different integrals, and that's how we're going to do it. We can do this deriving and integrating. So the antiderivative of 3 would be 3x, okay, which would be 13 and 2 there. So this would even split up further into 3 times 13 minus 3 times 2. Okay, and because this is all a whole bunch next, I'm going to use a big bracket here. Oops, I'm going to put the 5 out in front of this even, so that it applies to the whole thing. So here we have a 5. Okay, now when you integrate a derivative, you're just plugging in the bounds. Plug in the upper bound, plug in the lower bound. It's not the exact same thing as second fundamental theorem. That was where we derived an integral. Here we're integrating a derivative. You still got to deal with the bounds. This is where the table comes into play. What was f of 13? It was 6. Okay, what was f of 2? It was 1. This right here is sufficient for your final answer. Again, you don't have to simplify. You can, but you don't get any bonus points for doing so. All right, that was 23. You are going to do 24 and 25 on your own. You are going to get to skip 26, and then you will do 27 on your own, which is the last one. Okay, so knocked quite a bit of that packet off.